Hi, everyone, and welcome to section 4.1, quadratic functions. So in this section, we'll be going over quadratics and their graphs and how to write them in different forms. So we're going to try to understand the definition of the quadratic function and its graph. We're going to graph quadratic functions written in vertex form. We're not going to do completing the square. So we're not going to do number 3. Definitely not. We are going to graph quadratic functions using the vertex formula. And then we're going to, if we're given a graph, we want to determine the equation of the graph. So those are the things that we're going to work on today. So what is a quadratic function? A quadratic function is a function of the form f of x equals ax squared plus bx plus c. So basically anything that has the highest degree term as a squared is a quadratic function. And this is called standard form. All right, so I had to pause it for a second. Hopefully I start over in the right place. So this is standard form. A, B, and C are all real numbers, and A cannot be equal to 0, because if A was equal to 0, then I would lose my first term and I would just have a linear equation. And every quadratic function has a graph called a parabola. And a parabola just looks like that shape, okay? If the a value, which is the number in front of x squared, is greater than 0, then the parabola will open up. And if it's less than 0, the parabola will open down. And we learned this when we were doing transformation of functions. If I have just positive x squared, it looks like that, it opens up. And this is negative, so that means it's a vertical transformation. It reflects over the x-axis, so it's negative x squared. And now here, without graphing, determine whether the graph of this quadratic function opens up or down. And all I really want to do is I want to look right here at -3, and that's my a. So a is less than 0 because it's negative, so it opens down. Okay, so now what are the things that we're going to be looking for to create this parabola? We have what's called the vertex, and the vertex is sometimes people call it the turning point. So if it's opening up, it's the lowest point on the graph. And if it's opening down, it would be the highest point. This is the vertex. This is the vertex. Okay. The axis of symmetry is actually what's drawn in here in green. This dotted line is the axis of symmetry, because that if you look on both sides of the line, that middle line, then you can see that they're the same. Like a butterfly has the same thing on both sides. You cut it down the middle. Well, you don't cut it, but if you look down the middle, both sides will be the same. So that's the axis of symmetry. And this would be x equals, and what we would have for the axis of symmetry is x equals basically the x value here. So if we call this a, so x is equal to a. If that's actually, I don't really want to call it a because we have another thing that we use for a. Let's just call this, let's just make it up. Let's say this is 3, then we would have the axis of symmetry, x equals 3, okay? And let me erase this. So at the y-intercept is where the graph crosses the y-axis. This is the y-intercept. And these 2 points right here, those are both my x-intercepts. Okay. We also call them real zeros. And you may hear the term roots. If you do, it's exactly the same thing. And then the domain and range. And one thing we know for sure is the domain for any parabola, the domain is always going to be negative infinity to positive infinity. All real numbers. I can plug in any value, right? Now, if A is greater than 0, which means it's opening up, right? Just like this one, we can see that my range, well, the smallest value that y can be is whatever the y value of the vertex is, right? So I don't know, we'll call this 4 for the moment. There's actually letters that we're going to use for that, but we haven't learned them yet, so I'm not going to start there. So it's going to go from 4, sorry, this is -4. So it's going to go from -4 to infinity. If A is less than 0 or it opens down, well, then it's going to go from -infinity to the maximum value of which is the y value of the vertex. Y value of the vertex. Okay, we'll see lots of examples, don't worry. All right, so a quadratic function is in vertex form if it is written like this. So this is a very useful form of the quadratic function because I can actually do a lot with this, and you'll see as we go along today. So the graph of a parabola, so this is our function, and the vertex is our h and k, which makes it easy to find like the most minimum or maximum value that there is. And we already talked about the parabola opens up if a is greater than 0, the parabola opens down if a is less than 0. And we actually did also talk about the domain and range for both of them. So here we notice it's starting, so now we have actual letters that we're going to use, our h and k. So if it's opening up, our smallest value in my range is k, and it opens up to infinity. If it opens down, it's going to go from -infinity to k. That's the highest point of the graph. So let's say we're given this equation, okay? And we want to find some things out about it. So what are the coordinates of the vertex? Well, I know in vertex form, we have f of x equals a times x minus h squared plus k, where hk is the vertex. So we already have it in vertex form. So the vertex we can find, so it's x minus h, well, x minus 2, so h must be 2, plus k, that's k. So here's h, and here's k, which means it's 2, 4. Does the graph open up or down? Well, we can see that the a value, even though there's no number there, is a negative, like a -1. So we know it's negative, it's opening down. And the axis of symmetry always is x equals h. In this example, the axis of symmetry is x equals 2. All right, so now we want to find our x and our y-intercept. I'm going to actually start with the y-intercept. Y-intercept is so much easier because basically x equals 0. Okay, so I want to find f of 0 is equal to negative 0 minus 2 squared plus 4, which is equal to negative. And then we have 0 minus 2 is negative 2, squared is 4. So we have negative 4 plus 4, which equals 0. So we know we have a y-intercept at 0, which means we have x, when x is 0, y is 0. Okay? The x-intercept, we're going to find it by saying y equals 0. Or that's the same as f of x equals 0, right? So we say 0 is equal to negative x minus 2 squared plus 4. I subtract 4 from both sides, and I get negative 4 is equal to negative x minus 2 squared. And now I can multiply or divide both sides by a negative value, which basically makes both of these positive, right? And then I have to take the square root of both sides. And remember, when I take the square root of both sides, the square root of 4, well, is 2. But remember, we always have this plus or minus. Don't forget that, it's very important. And then this becomes just simply x minus 2 because the squared and the square root cancel. So I add 2 to both sides. Which gives me x equals 2 plus or minus 2. So what does that actually mean? It means x equals 2 plus 2 or 2 minus 2, right? So I have two solutions, x equals 4 or x equals 0. Those are my x-intercepts. And if I wanted to write them in order as an ordered pair, I'll write it over here on the side. Well, x is 4. Well, we know y is 0 because I already set it equal to 0. And I have another solution, x is 0, y is 0. And notice that's the x and y intercept. Okay? And I don't know why this is here, but this needs to disappear. All right. So now we have it in vertex form and we want to sketch the graph. So I start off by okay. Okay, so I know where the vertex is, right? Well, I don't even need to go there. We already know it from here. We know the vertex is at 2, 4. So I go to 2, 2, 3, 4. So my vertex is right around there. I also know my x-intercepts and my y-intercept, right? So I know I have 4, 0 and 0, 0. So 4, 0 and 0, 0. And if you notice, the halfway between 0 and 4 is 2, which is my vertex. Okay. And that's it. I just kind of connect the dots in the parabola type of form. And I shouldn't have gone up any. Let me see if I can do that a little better. So yeah, that's a little better. So it just comes down. And then if I want to find my domain, remember the domain of any quadratic is always negative infinity to positive infinity. There's no value of x I can't plug in there and get an answer. But my range, I can look here and I want to look at first, I want to say, well, what's the smallest that y could be? And so this is the top, that's the biggest that y can be. And it's going to go all the way down to where? To negative infinity. So I know it's negative infinity to positive 4, and it includes 4. So that pretty much takes care of it. So when it's in vertex form, graphing is pretty simple, right? I mean, we already know the vertex. We found our x and y intercepts, and then we just connect the dots. So we also have a formula to find the vertex if the function that we're given is in standard form, excuse me. So where does that come from? Let me just show you real quick so it's not something more to memorize. Let's say you have a quadratic and you want to find, and you want to use a quadratic formula, right? So I know as long as I set f of x equal to 0, then I can say x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. This is something you really need to memorize. You're going to need it forever. As long as you're taking math, you're going to use the quadratic formula. Okay, so I can also separate that into two fractions. That's the same as negative b over 2a plus or minus the square root of b squared minus 4ac over 2a, right? So where is the vertex? This is the vertex, or this part right here is the vertex. That's not, it's the x value of the vertex, okay? And then what the y value says is just all you have to do is plug in whatever you get for x into the formula, and then we'll find the y value of the vertex. So for example, this is in standard form, and I want to complete what's coming next. But first, I need to get it into vertex form, right? So I'm going to start by saying I want to find h comma k, which is my vertex. So I can say that h is equal to negative b. So if I look at this, this is a, this is b, and this is c. So that means that h, well, let me write it here. A equals 2, b equals negative 4, and c equals negative 3. So now if I plug it into my formula, my vertex formula, which is h equals negative b over 2a, I get negative 4 over 2 times 2, which equals 4 over 4, which equals 1. Okay, so, oops, so sorry. Yeah. Okay, hold on one sec. Okay, so now how do I find k? Well, I need to find what number goes when x is 1, what is y? So I basically say f of 1, which is from the previous slide, the same as saying f of negative b over 2a. That's where that comes from. But my negative b over 2a is 1. So f of 1 is equal to 2 times 1 squared minus 4 times 1 minus 3, which is equal to 2 minus 4 minus 3, which is equal to negative 5. So if I want to put this in vertex form, I now know my vertex, right? I know my h and I know my k. So I can say in vertex form, this function is f of x is equal to, well, I already know my a. Let me write vertex form again here for you. F of x equals a times x minus h squared plus k. So a, we already know, is 2. X minus h, well, we know h is 1. Squared plus k, well, plus -5 would just be -5. So this is the equation of, this is the same, these are equivalent. This is standard form, and this is vertex form. Okay. So now it asks, what's the vertex? Well, I can look back, but I can look right here. The vertex is 1, -5. The parabola opens up because A is greater than 0. The equation of the axis of symmetry, remember I said x equals, and it's always going to be h. So for ours, x equals 1 is the axis of symmetry. Now, if we want to find the x-intercepts, we have to say y equals 0. Okay? And so now I have to solve this. Let's see, do I have enough room? You know what? Let's put another slide so I don't have to squish. All right. So I'm finding the x-intercepts, and my function is this. So let's copy it and put it here. And I want to find my x-intercept. So my x-intercept, what do? I set y equal to 0. So that means this whole thing is equal to 0. So I get 0 is equal to 2 times x minus 1 squared minus 5. I add 5 to both sides, and I get 5 equals 2 times x minus 1 squared. And then I divide both sides by 2. And I get 5/2 equals x minus 1 squared, right? But then I can just take the square root of both sides. So when I take the square root of both sides, don't forget there's always this plus or minus. So I have plus or minus the square root of 5/2 is equal to, and the square root and square cancel, and I get x minus 1. I add 1 to both sides, so I get x equals, so I'm going to add 1 to both sides, and I get x equals 1 plus or minus the square root of 5/2. And I can rationalize this, right? Because, you know, let's do the math just so that you understand. So I have 1 plus, and since they're both under the same radical, I can just separate them into the square root of 2 over the square root of 5. And if I want to rationalize the denominator, I multiply by the square root of 2 over the square root of 2, which gives me 1 plus square root of 5 times the square root of 2 is the square root of 10 divided by the square root of 2 times the square root of 2 is the square root of 4, which is 2. So that's why I multiply by the exact same square root, because when I multiply, when I want to get rid of the radical, I just multiply by the same thing, because this is really the same thing as the square root of 2 squared, which is 2. And then I also have my minus 1. That's just the plus 1. So I have this value, which is approximately equal to 2.58. And then I also have x equals 1 minus, and I'm not going to do all the same work, but I'm just going to say the square root of 10/2, which again is approximately negative 0.58. Okay, so those are my x-intercepts. Y-intercepts are much easier. I think I can actually do the y-intercept. Oh, that we didn't ask for it. Okay, x-intercept. Now we're going to find the y-intercept a lot easier. The y-intercept is x equals 0. And when x equals 0, we just get f of 0 is equal to 2 times 0 minus 1 squared minus 5, which is equal to 2 times negative 1 squared, which is really just 1. So I'm just going to let that go. 2 times 1 is 2, minus 5, which is equal to negative 3. Okay. So now let's sketch the graph. Let's see what I can do here with this. So first thing I really want to do is I'm going to put in, let me put some the lines here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so we know this is negative 5, right? And let's see, what else do I want? I don't want to put all the numbers. It'll just take, it'll get messier. Okay, so we know the vertex. Let's put the vertex in first. We know the vertex that we found many times. I could find it without going back, but I want to show you. Nope. Nope. Oh yeah, actually, here's where we found the vertex. H comma K. So we have our vertex is 1 comma negative 5. Where did I? Here's our vertex, 1 comma negative 5. So I go 1 comma negative 5. There's my vertex, which I know is the smallest value. Okay. And then I really need my X and Y intercept. So I know my y-intercept is right on this page is negative 3, which means my graph is going to go through that point. And then my x-intercepts, we just did before, is negative 0.58 and 2.58. So again, I just have to approximate that. So negative 0.58, let's say, is right there. And 2.58, 1, 2, let's say, is right there. Okay. And then that's it. I have all the information that I know, so I'm just going to connect the dots. Nope. I'm going to miss. Sorry, guys. I know this is not that easy to draw like on this. Pretend that went through that other point. And so now we have the sketch of our graph, and we're going to find the domain and range. So again, we said the domain of any polynomial, and a quadratic function is a polynomial, is always negative infinity to positive infinity. And the range, notice this negative 5 is the smallest that it goes, right? So I start at negative 5 and it continues on to infinity. And that's basically it. We did everything that we need to do for this function. Okay. All right, so now it says, given the quadratic function, this is our quadratic function. It is in standard form, and I'm going to use the vertex formula to find the vertex. So remember, I want to find h comma k, and I know h is equal to negative b over 2a. Okay, so let's do that first. I look at my equation here, and I know a is equal to negative 2 right there. B is equal to negative 4 right there. And I don't need C, but this would be C if I needed it. And so the H value, or the X value of my vertex, is going to be equal to negative B over 2 times A. And that equals positive 4 over negative 4, which equals negative 1. okay? Then I need to find K. How do I find K? K is the Y value of my vertex. So to find K, that's the same as f of -1, because I already found my x value for the vertex. So I plug that in, and I get -2 times -1 squared minus 4 times -1 plus 5, which is equal to -2. And then -1 squared is 1, so I don't really need to do anything with that, plus 4. -4 times -1 is plus 4, plus 5, which is equal to 7. So use the vertex formula to determine the vertex. I just did. My vertex is at -1, 7. Okay. Does the graph open up or down? Well, it opens down because a is less than 0. It's -2. What is the equation of the axis of symmetry? The axis of symmetry always goes through the x value of my vertex, which means that x equals -1 is my axis of symmetry. Find the x-intercept. Okay, so again, to find the x-intercept, I say y equals 0. So I find 0 equals, actually, I don't want to use this equation because then I'd have to factor, and it really is not the easiest way. Oh, and another way you could do it, so you could either go back, actually, maybe we'll do it both ways. You can either go back to the vertex formula. So let's go back to the vertex form. So this is the one way we could do it. We know our vertex is at -1, 7, and a is -2. So we have -2 times x plus 1 plus squared plus 7. Let me just make sure I got that right. -1 plus 7. Yes. So there it is. I can actually find my x-intercepts from that. And how I would do it is I would subtract 7 from both sides. Right? I would then divide both sides by -2, which gives me 7/2 equals x plus 1 squared. I take the square root of both sides. When I do that, this becomes plus or minus. So I get plus or minus the square root of 7/2 is equal to x plus 1. Subtract 1 from both sides. Let me do this. So I'm going to subtract 1 from both sides. And I get x equals -1 plus or minus the square root of 7 over 2. Okay. And then I can use my calculator to find the answer. The answer to this is going to be, let me just check my calculator, make sure I get it right. And I have divided by 2, take the square root. So I get -1 plus or minus, that doesn't seem right. Let me do that one more time. Yeah, square root, there we go. 1.87, which means I have x equals -1 plus 1.87, or x equals -1 minus 1.87, which gives me x equals approximately, not exactly, but approximately 0.87 or negative 2.87, right? Those are my two values. Now, what's the other way I could do it? If I didn't want to go through all this, I can plug it into my quadratic formula. So let's do that. Let's make a new slide. Just because I want to give you options, whatever you feel most comfortable with is fine with me, as long as you get the right answer. So let's grab this, copy it, paste. All right, so I can just use the quadratic formula, which says x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a, which is equal to negative 4 plus or minus the square root of negative 4 squared minus 4 times a times c over 2 times a. That gives me 4 plus or minus the square root of 16. And then I have minus, so this becomes plus. And then I have 4 times 2 is 8 times 5 is 40 over negative 4, which is equal to 4 plus or minus the square root of 56 over negative 4. And I can keep simplifying this, and I would get negative, let's do it like this. So I have 4 divided by negative 4 plus or minus the square root of 56 divided by negative 4, which gives me negative 1 plus or minus, and we can simplify the square root of 56. So let me show you how to do that in case you don't know, because you might have to do this without a I mean, you can use your calculator, but you might have to find, they might ask for the x-intercepts in. And if they don't want you to use the calculator, it'll say using radicals or get the exact value. So let me show you how to do it. 56. So I'm going to try to figure out what the square root of 56 is without it being with it being an exact value. So I'm just going to use a factor tree first. So I can say 56 is 2 times 28. And 28 is 2 times 14, and 14 is 2 times 7, right? So this becomes 2 times 2 times 2 times 7. So if I want to find the square root of 56, which is the same thing as the square root of 2 times 2 times 7, that's the same as the square root of, and since I have 2 times 2, I'm going to say this is the same as the square root of 4 times the square root, and it would be of what's left, 14, right? But I know the square root of 4 is 2, so it's 2 times the square root of 14. So now I can plug this in, and I can say this is 2 times the square root of 14 divided by negative 4, which is equal to negative 1 plus or minus. I can simplify this 2 and this 4 and make it a 2. So I get the square root of 14 over 2. And why can I drop that negative? Because I'm going to get both the positive and negative anyway. So I don't have to worry about that negative in the plus or minus side. So that means that x is equal to negative 1 plus the square root of 14 over 2, or x is equal to negative 1 minus the square root of 14 over 2. And again, the values that I gave you before, it'll equal the same values, 0.87 or negative 2.87. So x equals 0.87 or negative 2.87. And you can get your calculator out and verify that, but either way is fine. It'll give you the same values, okay? So now we want to find the y-intercept. Again, the y-intercept is much easier. So x equals 0. If x equals 0, then when I plug this in, this becomes 0, right? Because it's 0 times negative 2. This becomes 0 because it would be 0 times negative 4. So when x equals 0, y equals 5, which is my y-intercept, 0, 5. Okay. And then let's sketch the graph. Okay, so again, this isn't going to be very easy, but I will be happy to do it. So we know the vertex. We have the, let's see how far back. So we have the vertex, negative 1, 7. So here's negative 1. And 1, 2, 3, 4, 5, 6, 7. There's negative 1, 7, and we'll plot a point there. Okay. And then we know that the y-intercept is 0, 5. Well, that's an easy one. 1, 2, 3, 4, 5. So that's going to be here. And then we need to graph our two x-intercepts. Our x-intercepts are 0.87 and negative 2.87. That's the hard part. So again, we're just going to guess 0.87. Let's make it right here. And negative 2.87 we'll make right here. And now I basically have enough to sketch my graph. So it's going to go like that. And then this side's going to come through there and go down here. Okay. So I've sketched the graph. And now I have to state my domain and range. My domain is always negative infinity to positive infinity. And my range, well, it's going up to 7, but it's starting down all the way down at negative infinity, right? So I always go from smallest to biggest. So the smallest value is negative infinity. And the largest value here is going to be 7. That's my vertex right here. This my vertex is negative 1, 7. Okay. And that's it. I've done everything. So now we're going to do the opposite. I don't actually think this is in your homework, but I think it's interesting enough that maybe it'll help you understand better, and it'll take another minute. So we're given a graph and we want to be able to write the equation of this quadratic function, given that they give us this graph. So what are they asking us? Is the leading coefficient positive or negative? Well, it's definitely negative. Why is it negative? Because it's opening down. Okay, and we say leading coefficient, which means the first one when it's in standard form. So, like for example, here the leading coefficient would be negative 2. Also, you could just say it's your A. Okay. So it's the same as the leading coefficient here. Let's do it like this. The leading coefficient, what it means is the same thing as A. Okay. What is the value of H and what is the value of K? Well, those are the values of my vertex. So I look here, my vertex is negative 1, 4, which means H is equal to negative 1. And K is equal to 4. So I know a lot now about this function. And now what we want to do is we want to find A. Well, we don't know what A is. We know it's negative, but that's all we know. So we're going to put it in our form, in our vertex form. So we have X minus H squared plus K. And we know h and k, right? We know from here, h equals -1 and k equals 4. So I'll just change this. So this is going to be equal to a times x plus 1, because it's minus minus 1, and then plus k, and k is 4. Okay, and that is what f of x equals. Now, how do we find a? Well, we look at our graph, and if you notice, they're giving us one other point. They're giving us this point 0, 3. We need another point besides the vertex. So they told us we have this 0, 3, which means I know 0, 3 has to be on our graph. So what I'm going to do is, well, f of x equals y, and y equals 3. So I get 3 equals a times, well, x is 0. So I get 0 plus 1 plus 4. 3 is equal to a times 1, which makes it a, plus 4. I subtract 4 from both sides. And now I know that a equals -1, okay? Which is good because we said it was going to be negative. So now I just plug everything in, right? So I have f of x is equal to, and I don't have to put the 1, I can just put negative x. My vertex is -1, so it would be plus 1. I'm sorry, my x value of my vertex is -1, which makes it plus 1 squared, and then plus 4. And that's the equation of this function in vertex form. Now, write the equation of the function in standard form. Well, I have to do a little bit of algebra. So let's see. I have f of x equals negative, and then the x plus 1 is squared, which is the same as saying x plus 1 times x plus 1, which I will have to FOIL, plus 4. And that gives me negative. And then x plus 1 times x plus 1 is, first times first is x squared. Outer times outer is x. Inner times inner is x. So x plus x is 2x. And then 1 times 1 is obviously 1 plus 4. And that gives me, let's go this way. I'm going to distribute that negative. I get negative x squared minus 2x minus 1 plus 4, which means f of x is going to equal negative x squared minus 2x plus 3. And that is it in standard form. And that's it. That concludes the lecture on 4.1. Yeah, if I went through everything. Yep. So thank you for watching, and I hope it helps.